In this video, I'm going to solve every question from the Mathematical Association's Primary Maths Challenge from 2024. That's a maths challenge aimed at students aged 9 to 11, but often also taken by younger students as well. And if you're preparing for that challenge or just want to do even more of these questions, then take a look at my free course, Get Ready for the Primary Maths Challenge. There you can practice all of these questions as well as questions from other papers, and each question has a video hint as well as the full video solution. So you can have a go at the question and watch the hint if you're stuck. That really gives you the best chance of getting the answer by yourself. You can then check if the answer is right before you watch the video solutions. It's a really great way to prepare for the Primary Maths Challenge. There's also a huge overlap between the Primary Maths Challenge content and 11 Plus Maths. In fact, I've helped loads of students prepare for 11 Plus at all of the UK's top schools, after also working as a teacher at Westminster School and Dulwich College in London. And at Dulwich, I also wrote the 11 Plus Maths paper for 4 years. So you might also want to take a look at my complete 11 Plus course, which has over 100 video tutorials and more than 1,000 original practice questions that I wrote myself. Over at that course's website, there are also loads more free courses to prepare for other maths challenges for ages 7 up to 18 and for school maths as well. So I really hope that you'll take a look over there after you've watched this video. But if you want to watch the video solutions here on YouTube instead, I'll get on with them now. I'm going to put timestamps below so you can jump to the questions that you need. Or if you'd like to work through the whole paper with me here, you can really get a lot from this video. So the best way to do that is to do the questions yourself. That's how you really benefit from these papers, not just by watching me passively, but having a go in between each question. So start at question 1, pause before I start the solution, have a go at it yourself, and then see if you've got them right. So let's get on now with question 1. This first practice question asks us to work out the value of 5 plus 50 plus 500. You can just do that in your head, or you can do it as a column addition or any other method you want. We'll just get the answer here of 555. So the answer there is C. This question really to get you used to these multiple choice questions, but they're going to get a lot harder. How many spots has a 6-sided dice? Well, any dice has just those 6 numbers 1 to 6 on them. So if we add those together, 1 plus 2 plus 3 plus 4 plus 5 plus 6, add those together carefully and you will get 21 for an answer here of C. The overnight boat from Birkenhead to Belfast leaves at 10:30 p.m. and takes 8 hours. What time does it arrive in Belfast? I think the easiest way to think about this is to think that at 10:30 p.m. there is 1 hour and 30 minutes until midnight. So what amount of the journey is left? Well, 8 hours minus 1 hour and 30, that's 7 hours minus another half an hour, that's 6 hours and 30 left of the journey after midnight. And 6 hours and 30 minutes after midnight, of course, is the time we usually call 6:30 a.m. And so the answer here is B, 6:30 a.m. Well done if you got that. My dog Crunch has lived for 104 weeks. How old is he? Well, we need to know for this question that a year has 52 weeks in it. So 2 years will be 2 lots of 52. That will be 104 weeks. You could only waste time on this question, I suppose, if you tried to do 104 divided by 52 and weren't quite sure how to do the division. But here, the whole number answers, we've either got 6 months, a year, 2 years, 3 years, and 4 years. Makes it very sensible just to test out how many weeks there are in 1 year and then 2 years, and we'd have gone to higher numbers of years if necessary, rather than trying to do a formal division of 104 divided by 52, which of course will give us 2 here for the answer of 2 years. The temperature in Geneva this morning was minus 5 degrees Celsius. It then increased by 2 degrees Celsius. What is the temperature now? Well, minus 5 is a negative number. When we add 2 to that, minus 5 plus 2, that makes it a smaller negative number. So the false answer here that some people will have gone for is minus 7. That would actually be 2 degrees lower than minus 5. That would be minus 5 minus 2. But minus 5 plus 2 brings us up to minus 3. And there the answer is C, minus 3. So if you got that one wrong, just do a little bit of work on negative numbers. You can find sections on that in my 11 Plus course, for example, and perhaps elsewhere on the website in the future. But the answer here is minus 3 degrees Celsius. On an expedition, Sultana walks 1 mile northeast. She then turns 90 degrees anti-clockwise and walks another mile. She then turns 45 degrees anti-clockwise and sets off to walk a 3rd mile. In which direction is she now walking? So here are the compass points, north, east, south and west. You need to remember which directions those are in. And if we start in the northeast direction, that will be roughly in this direction then, and we're going to go 1 mile, and then at the end of that mile turn 90 degrees and then continue walking, so take a right angle in that direction. When we put that on the compass here, we can see exactly 90 degrees anti-clockwise from northeast will take us to northwest, so that's the direction we'll be pointing in. Then at this point, after another mile, we're going to go 45 degrees anti-clockwise, and if we look at the compass again, 45 degrees anti-clockwise from northwest will take us to west. So the answer here is A, west. And you can see actually that once we've done this question, we realize that the distances didn't actually matter at all. So if you get a question like this, you could do it without drawing out the distances or worrying about that, with just thinking about which direction we've rotated in and which way we are facing by the end. So the distance is not important at all for this question. This shape has been cut from a 3 cm by 3 cm by 3 cm cube. 4 pieces, each 1 cm by 1 cm by 3 cm, have been removed. What is the volume of the shape now in cubic centimeters? There's various ways you could get the answer here. You could do something like adding together various parts that you can see. You could even treat it as a prism, if you know what that means, and do the area of the side multiplied by the depth of that prism. But I think the easiest way to approach this problem is to actually follow the route that's been given in the question. It says we start with a cube, and the original cube is 3 by 3 by 3. That would be 27 centimeters cubed. And now let's think about what we've removed from that. We've removed 4 pieces, and each of those are 1 by 1 by 3. So each of them individually are 3 centimeters cubed. 4 of them together is 12 centimeters cubed. And the volume that's left then is the difference between those, 27 minus 12, which is 15 centimeters cubed. As I say, there are lots of other ways of doing that, but it's very natural to do it here and very efficient to do it by subtraction. And that's the way that I would approach this question. But if you've done it another way and you've got 15 as well and got the answer of C, that's just as good. So well done. Tripoders each have 1 antenna, 2 arms and 3 legs. Hoppers each have 3 antennae, 2 arms and 1 leg. How many legs will 3 tripoders and 3 hoppers have in total? Well, the key to this question, or at least the key to making it easy, is to realize that actually it's only the legs that matter here. So you can have a look at the pictures and work out which creature is which, but we're only asked how many legs in total they have. So all we care about is that tripoders have 3 legs, and there's 3 of those. So that will be 3 times 3, or 9 legs in total. And the hoppers have just 1 leg each, that's why they're hopping, and so they have 3 times 1 legs in total, which is 3, and if we add those together, 9 plus 3 is 12, for a nice final answer there of E. Tom draws a grid of 9 small squares as shown in the diagram. It has 4 horizontal lines and 4 vertical lines. Next, Tom draws a similar grid of small squares using 5 horizontal lines and 5 vertical lines. How many small squares are there in the new grid? The idea of this question is that you might not need to actually draw it out to work it out, but I'm going to for the explanation. So let's make a copy of the diagram we've started with, and we're basically saying what happens if we have 1 extra horizontal line and 1 extra vertical line. That will give us 5 horizontal lines and 5 vertical lines instead of 4. Notice it's not the number of lines of squares, it's the number of actual physical lines. So this original diagram has 4 vertical lines. That's why they say that in the question. Otherwise you might say, do they mean 3 columns of squares or 4 lines? Now at this point you probably don't need to fill in the diagram. You can see you're going to end up with a 4 by 4 square, and 4 times 4 is 16, and that's the answer to this question. And you may be able to do that without doing any drawing at all if you're very fast. What is the answer that this number machine always gives you? It says think of a number, then add 1, multiply by 2, take away double the number you thought of, and subtract 1. This is a maths challenge question, and we've got multiple choice options here, and there's no option for more information needed, or it could be different answers. It tells you in the question that the number machine is always going to give you the same answer regardless of the number that you start with. So we don't have to question that. We can just pick any number we like and substitute it in, and we know we're always going to get the same number out if it's a well set problem. I will show you why it's the case in a second as well. But to do the maths challenge in good time, I would recommend just getting the answer and coming back and thinking about that later. You've only got 45 minutes to do the whole primary maths challenge, so you need to get on with it a little bit. Choose any number then. Let's start with 1, and I'm going to add 1 to it to get 2, and then I multiply that result by 2. 2 times 2 is 4. Take away double the number you thought of originally, so I started with 1, so double that is 2. I'm going to take that away. 4 minus 2 is 2. And then we're going to subtract 1 from that, and we get back to 1. Interestingly, in this case, it's also the same number that I started with. I didn't know that when I chose the number, but that's not the point of this question. The point is that we always end up with the number 1. You can try it with some different numbers. Perhaps you did use a different number. And to prove that it always works is also an interesting thing. You should really want to think about this, even if it's not needed to answer the question. If we started with a number, let's call it x, this represents starting with any number, it doesn't matter what it is now. If I add 1 to that, I get x plus 1. If I double it, I get 2 lots of x plus 1. And again, if you haven't done this much algebra yet, don't worry too much about this. You'll do this very soon, I'm sure. And then I'm going to subtract 2 times the number I thought of, which is x, so let's subtract 2x and then subtract 1. Now this 2 lots of x plus 1 is 2 lots of x plus 2 lots of 1, so it's 2x plus 2. Then I can subtract the 2x and subtract the 1. So the 2x's here cancel out. I've got a plus 2x and a minus 2x, and then I'm just left with the numbers 2 and minus 1. So you can really see that whatever value of x you put into here, you will always get 1 out of this machine, and that's why it's a sensible question to ask. I divide 265 by a certain number. The answer is 11 with a remainder of 12. What's the number I divided by? Now, before you rush into this question, let's just really think about division with remainder. So we're saying we've divided by 11 and got 12 left over. So my question is, what number would have given you a remainder of 0? Well, it would be a number that is 12 smaller than 265, because the remainder is what's left over once we've done the division. So let's just get rid of that leftover, and we'll have 253. Now we know when we divide this by 11, that will give the number that we're looking for. So if I divided 253 by that number, I would get 11 with no remainder. So let's just do 253 divided by 11. 25 divided by 11 is 2 with 3 left over. 33 divided by 11 is 3. So the answer is 23. You can check that 11 times 23 plus 12 is 265, and that makes this question work. Here's question 10. The king penguins in the Scilly Islands Zoo, slightly different spelling to the Scilly Islands that really exist, Scilly without the C here. They love to play pyramids, where they stand on top of each other to see how high they can reach. Each row always has one fewer penguin than the row below it, as in the picture. Each king penguin is 100 centimeters tall. Greta the giraffe is 5 meters tall. How many king penguins would be needed to form a pyramid which has the same height as Greta? They like to throw in some different units here to throw you off in these questions, but of course 5 meters is 500 centimeters because a meter is 100 centimeters, and that's 5 lots of 100 centimeters. So Greta's height of 5 meters is 5 times the height of one of the king penguins, so that means we need 5 rows in the pyramid, and we can add the numbers together here. There'll be 1 in the top row, 2 in the next row, then 3, and then 4 in the one below it, and 5 in the one below that. And if you add those together, you get 15 penguins in total. So the reading in this question, I think, is as complicated as the maths. Well done if you got that. Patrick wants to choose a 4-digit code for his bicycle lock using each of the digits 2, 3, 5, and 7 once and only once. How many of the possible codes start with the digit 2? So you can just imagine there being 4 spaces here that I've added to the question for the digits. And it's an easier question than it looks perhaps, because in all of them, the first digit is 2. So we actually don't really need to worry about that. We can just say, oh, we've got these 3 other spaces to fill in, and we've got 3, 5, and 7 to put in these boxes. And the method I'll use here is what we call systematic listing. We're going to just list out all of the options in a systematic, that means an ordered way. So we'll go from the smallest number, like as a 3-digit number, 357, to the largest ones. So I'll do all the ones that start with a 3 first, so 357 and 375. Then I'll do all the ones that start with a 5, 537 and 573. And then I'll do all the ones that start with a 7, 735 and 753. And actually at that point, we know, because we've done it systematically, that we've got them all. We won't have missed any. So there are 6 options in total there. When you get really good at these sorts of problems, and if you do some of my other online courses perhaps, you will learn that a quicker way to do this would be to just say 3 times 2 times 1 is 6, thinking about there being 3 options for the first square, 2 for the second, and 1 for the last one. And there's lots of really interesting counting sorts of problems that build on top of this as well that you can learn. But for the primary maths challenge, I think systematic listing will be the right approach for most questions. Question 12 here is a nice averages problem. We've got 6 runners in a club that have won a mean of 5 races. A 7th runner joins the club and the mean number of races won is now 6. How many races has the 7th runner won? Well, the formula we want to use here is that the mean is equal to the total divided by n, where n is the number of things we're taking the mean over. So here it'll be the number of runners. And we can rearrange that to give that the total is equal to the mean times n. We use this a lot in these sorts of averages problems. So when there are only 6 runners in the club, the n is 6 and the mean is 5, so the total number of races that those 6 people must have won is 5 times 6, or 30. When the next person joins, there's now 7 runners, so the n is 7, and the total number of races won then is 6 times 7, because the mean is now 6. So 6 times 7 is 42, and this extra runner then must have contributed all of those extra races. So 42 minus 30 is 12, and that new person must have won 12 races to make those totals correct. In question 13, we've got 2 rabbits are eating a carrot, which is 20 centimeters long. One eats from one end at 2 millimeters per second, the other eats from the other end at 3 millimeters per second, and we want to know how long is it before they finish their carrot. So we're going to think of this as the 2 rabbits completing this task together. It doesn't really matter that they're eating from different ends, particularly here. It's just that every second, one of them eats 2 millimeters and the other one eats 3 millimeters. So in each second, we're getting 5 millimeters of the carrot eaten in total. 2 plus 3 is 5. Now 20 centimeters is 200 millimeters. Again, they're putting different units in here just to add a little bit of extra challenge. And so if we do 200 divided by 5, you can do that directly, or you could times top and bottom by 2 and get 400 over 10 if you want to make it easy. That would give us 40 seconds then. So in each second, 5 millimeters is eaten. 5 times 40 is 200, so it takes them 40 seconds to eat the whole carrot. Question 14, what fraction of the rectangle is shaded? There's lots of different ways you could go about this question. Actually, I'm going to take quite a direct route using the formula. So the area of a triangle is a half base times the height. And for this shaded triangle, the base is 5 and the height is 3. So the area is just a half times 5 times 3. We'll think about working that out in a second. But just to be clear here, you're probably familiar with the area of a triangle formula, half base times height. And just remember that that still works when the perpendicular height lies outside of the base. So in these 2 different triangles here, if you took these lengths to be the base, the perpendicular height in the first triangle is here and in the second triangle is here. And in both cases, that formula, half times base times height, works just as well here. So that 3 is the perpendicular height for this triangle. Then the area of the rectangle is just base times height, of course, and the base of the rectangle here is 6. It looks a bit like a B, but I mean a 6 there, also the base, I suppose. So that's 18. But to work out the fractions shaded, I want to do the area of the triangle divided by the area of the rectangle. Now you could just work out these numbers and then put them into a fraction, but we could put them into a fraction straight away. Then we could cancel out the 3s. That might save us a little bit of time here. And then we can see that the answer that we're looking for is just a half times 5/6, which is 5/12. Again, lots of the techniques here, quarter 11 plus style maths, and I've got a full course on that on the Mathsaurus website as well, but also it comes up a lot in all of the challenges, and fractions really something very well worth getting very good at this stage. Very, very useful topic for all sorts of reasons that I won't go into anymore here. You could do this in other ways, as I say. You could work out that the area of the triangle is 15 divided by 2, which is 7.5, and then go straight to a fraction like that as well, if you want to. So different ways of getting there. You could do some square counting in different ways as well, but I quite like a direct answer there based on the formula. So however you've done it, well done if you got the right answer. Question 15, Beth Shriver is cycling at 20 miles per hour. How long will it take her to cycle 2 miles? Well, if we think about 20 miles per hour, Well, that means you're doing 20 miles in each hour. So how long will it take to do 2 miles? Well, assuming we're going at a constant speed here, which we are, I think, 2 miles is 1/10 of 20, or you're doing 20 divided by 10 to get to 2. So it's going to take 1/10 as long to do 2 miles as it does to do 20 miles. Now 1 hour divided by 10 then gives us 1/10 of an hour. So let's write that as 60 minutes in an hour. Dividing that by 10, we can see that we get 6 minutes. So it will take 6 minutes to cover the 2 miles. Question 16 is a tricky little perimeter question. The perimeter of a rectangle is 30 centimeters and the longer sides are 5 centimeters longer than the shorter sides. What's the area of the rectangle? I'm going to try and do this with as little algebra as possible to begin with, but I will just label the side of the rectangle X, but you'll see I'm not going to use it in a really algebraic way to begin with. We can say that if I split the rectangle like this, because the longer side is 5 centimeters longer than the shorter side, I could say, okay, let's take that shorter side and call it X and make it part of the longer side. So there would be an X and a 5 on the longer side. Now, that would leave us with a square then on the left because the base and the height are both X. We've got an extra 5 centimeters top and bottom there that make up the rectangle compared to the perimeter of that square. So if the perimeter of the rectangle is 30, the perimeter of the square would be 20 then, taking off those 2 5s, and it would have 4 equal side lengths of length X, so 20 divided by 4 is 5. Okay, I've written it down a little bit algebraically, but you don't strictly need it here. So that means that the base here is 10 and the height is 5, and the area is 10 times 5, or 50 centimeters squared. If you're comfortable with algebra, it's probably quicker just to write it down algebraically directly, call the height there X and the base X plus 5, and then we would just get the X plus X plus X plus 5 plus X plus 5. That's 2 lots of the base and 2 lots of the height, all add together to give 30. Combining terms, you get 4x plus 10 equals 30. Subtract 10 from each side to get 4x equals 20, and again divide by 4 there to get x equals 5. It's exactly the same steps, just written down with algebra, and then once we know that x is 5, again we can work out the area is 50 just as before. So no need for too much algebra there, but algebra is the language which so much of maths is written in. So the sooner you can do a bit of algebra and get used to it, the better really, because it does come in handy. Here's question 17. In a maths challenge there are 48 marks. Jamie scored 50% of the total marks. Mimi scored 3/4 of the total marks. Vlad scored all but 6 of the total marks. Sam scored 11/12 of the total marks. And Dipesh scored 45 marks. Who scored the most marks? You might start working this out from the beginning, and that's what I'm going to do here, and I'll work out everyone's scores to show you. But if you realise that you're looking for who scored the most marks, you might realise that we don't need to work out all of them if some of them obviously haven't got the highest mark. But let's go through them one by one. Right, Jamie, you might not need to work out here, clearly hasn't got the highest mark here. 50% of the total is 24 out of 48. Mimi then, also 3/4 of the total marks. We know 3/4 is less than 11/12, so we could have ignored these two. 1/4 would be 12, so 3/4 would be 36. Vlad gets all but 6, so 48 minus 6 is 42. Sam gets 11/12, so 1/12 would be 48 divided by 12, which is 4. So 11/12 is 48 minus 4, which is 44 marks. And then finally, Dipesh, easy to work out, gets 45, and 45 is higher than all the other options. So Dipesh scored the most marks. And as I say, we could have maybe not worked out all of those, but it doesn't take too long to do them all, just to check our answers if we want to. In question 18, Henry Hedgehog eats 4 slugs for every 3 snails. 1 week he ate 28 slugs and snails altogether. How many slugs did he eat? I'm going to write this down as a ratio. You could perhaps avoid writing it that formally, but I think it makes it easier. We've got the ratio of slugs to snails here is essentially 4 to 3. That's just saying for every 4 slugs, we eat 3 snails. So in total there are 7 parts to that ratio. 4 plus 3 equals 7, and 28 divided by 7 is 4. So what I want to do is to scale this ratio up by 4. 4 times 4 is 16, and 3 times 4 is 12, right? And I realise that because I've got 7 parts in the ratio, and 7 times 4 is 28, which is the total number of slugs and snails eaten. Again, this is another topic that we go into a lot in the 11 Plus course, which is very suitable for people taking the primary maths challenge as well, whether or not you're taking 11 Plus maths. Lots of really good maths for this age level in there. But we've done the question here. We now know that there are 16 slugs and 12 snails, and so the answer here is 16. Well done if you got that. Question 19 says there are 40 tourists at Salvo's Cafe. They all order either a hot chocolate or a panini or both. Salvo takes 27 orders for a hot chocolate and 30 orders for a panini. How many tourists ordered a panini but not a hot chocolate? It's really important here that we know that everyone orders something, because there are 27 plus 30 or 57 orders for some things in total. But there's only 40 customers and they all order either one or two things, because they all order at least one thing. If the 40 customers all just ordered one thing, there would be 40 orders. But we've got 57 orders. So there's an extra 57 minus 40 or 17 orders. And that must mean that there are 17 people who've ordered two things. i.e. they've ordered both a panini and a hot chocolate. So if we look at the number of hot chocolate orders and panini orders, we're interested in paninis here. So there were 30 orders for a panini in total. 17 people ordered both. So 17 of those people also ordered a hot chocolate. 30 minus 17 or 13 must have ordered just the panini. And the answer here is B13. Now you could write this with a Venn diagram if you want to, but it's not really needed here. I'll just show you the diagram because it's quite a common way of representing this information. We'd put paninis and hot chocolates in their circles here. There'd be 17 that ordered both, 13 that just ordered a panini then, and that would leave 10 that ordered just a hot chocolate, and we can see all the information here. And there's nothing outside this Venn diagram. Sometimes we put a box around this and then say how many people ordered neither, but everyone ordered something here. So that's a topic you might want to look at and can be useful for harder problems like this. Here's question 20. Dr. Rupert Fuzzy needs to label the coat hooks in the cloakroom with the numbers 1 to 100. He has to buy the digits separately. How many of the digit 1 does he need to buy? Again, this is a long-winded way of saying if I wrote down all the numbers from 1 to 100, how many times do I write the number 1? So let's think what happens here. Now, you might not need to write all of these out yourself, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. I'm just going to write some of them out here. I've done it earlier. And once we get past 19, the only time we get ones again will be in the numbers that end in a 1 here, 21, 31, 41, 51, etc. And of course, at the very end, the 100 has a 1 in it. So I don't need to write out the full 100 numbers here. We could just count the number of ones on the page here. But if I was doing this without having written anything down, which you can do if you get good at these, I would have thought about it this way. I'd have said, I know there are 10 ones in the tens digits, right? In the 1, the 11, the 21, the 31. I'm not counting the 2 ones in the 11 twice here yet, just once. I'm just counting the ones in the units digits. So the units digits have 10 ones there. Now, in the tens, there are 10 numbers with a 1 in the tens digit. Again, in the 11 here, I'm only counting the first 1 this time. And so there'd be 10 numbers here. So I know between 1 and 99, I'm using 20 ones in total. And then I get the extra 1 for the 100, and that gives me a total of 21, which of course at this point you could also do just by counting them because they're all written down on the page. But however you got it, well done if you got that right. Very easy to miss one here. So we've got through questions 1 to 20, and it changes a little bit from question 21. So question 21 to 25 are not multiple choice. You have to work out the answers and just write the answers down. They will be numerical answers. They could be whole numbers, fractions, anything else really. So it changes just a little bit for these last 5 questions. So let's have a go at those now. In question 21, Errol and Lauren keep bees. In Errol's hive, there are 45,000 bees to the nearest 1,000 bees. In Lauren's hive, there are 56,000 bees to the nearest 1,000 bees. To the nearest 1,000, what is the greatest possible difference in the number of bees in the two hives? So we have to think, what's the maximum number of bees that Lauren might have that would still round to 56,000 to the nearest 1,000? You might say 56,500. You wouldn't be quite right because it would be 56,499. 56,500 would round up to 57,000. As it happens here, because the final answer is going to be to the nearest 1,000 you wouldn't get it wrong if you did that overall. In fact, it would make the question easier, but we'll do it accurately. Errol now could have a minimum of 44,500. That's the smallest number that would round up to 45,000. So if I want to know the biggest possible difference, I want to think about the maximum number for the largest one and the minimum number for the smallest. So these would both be consistent with the information we're given. They both round to the numbers given. And the difference here then would be 56,499 minus 44,500. Now, if it had just been 56,500, this would be an easy calculation. It would give us 12,000. In fact, this gives us then 11,999. But to the nearest thousand, it's still 12,000. So the answer to this question is 12,000. So well done if you got that right. In question 22, Garita made a 3x3 grid as shown and put each of the numbers 1 to 9 in the cells. She then multiplied the numbers in each row and put the product next to the row. She also multiplied the numbers in each column and put the product under each column. Which number did Garita put in the cell marked X? So we've got these sets of 3 numbers that multiply together to give the numbers in the columns and also in the rows as shown here. There's some larger numbers and some smaller numbers, and if we can get away with it, it would be nice if we could just think about the smaller numbers, but we might have to think about the larger ones as well. But I'd always start these questions by thinking, what are the possibilities for the smallest numbers? Because if we can use that to narrow it down, we can get through this in a good amount of time. You might want to come back later and fill in the whole square. But let's think about that. So the smallest numbers, 35 and 27. Actually, if you think about the numbers from 1 to 9, the factors of 35 are just 5 and 7, and of course 1 and 35. So the only way we can multiply 3 numbers together to get 35 from 1 to 9, and they've all got to be different, of course, is 1 times 5 times 7. And that must be the 3 numbers there in some order. For 27 as well, this is where them being different also matters, because we can't just do 3 times 3 times 3. So the only factors of 27 then are 3 and 9 and 1. So it'd have to be 1 times 3 times 9. So there has to be a 1 in both that top row and in that left column. So that top left one must be a 1 then, because the 1 can only appear in one place. So now let's have a think about the other smaller numbers. So 48 here. Well, 48 has to have one of the other factors of 27 in its row, because it shares that middle left box here. So can it have the 3 or the 9? Well, 9 isn't a factor of 48. 48 is not a multiple of 9. So actually it has to be a 3 here, not a 9. And then the 9 must go at the bottom here. And 9 is a factor of 216. Looking at the numbers on the bottom here, the other thing I notice, although I'm looking at the larger number now, 336, it's very easy to tell it's not a multiple of 5 because it doesn't end in a 0 or a 5. So when I look at that 1 times 5 times 7 at the top, it must be the 5 that goes in the column with the 40, and then the 7 must be in the 336, and we can assume that 336 is a multiple of 7 then. You can check if you want to. So let's look at the 40 then in more detail. So 40 is 5 times these other 2 numbers. So those other 2 numbers, the x and the one below it, must multiply to give 8. And so the only way to do that is to do 1 and 8 or 2 and 4. But we've used the 1 already, so it has to be 2 and 4. If it was a 4 where the x is, then that middle row to get 48 would be 3 times 4 times something is 48. So that's 12 times something. Well, it would have to be another 4. It would have to be 3 times 4 times 4. So we can't do that because we can't repeat the 4. So it must actually be then that the x is 2, the other possibility, and we've got the answer to the question at that point. And we don't have to think so much about those big numbers. You can fill in the rest of the grid like this if you want to, and you can check that all of the numbers work out and that it really is a valid question. But in the maths challenge itself, once you've worked out for sure that it's 2, you could move on and come back to double check if you've got time, because you don't have a huge amount of time to get through these questions, especially these last harder ones. Here's question 23. Xanthe, Yoko and Zara are running around a circular track. They all start together. Speedy Xanthe completes 8 laps in the same time that Yoko runs 4 laps and Zara runs 3 laps. How many laps has Xanthe run in the first time they reach the start line together? Now, I want to say something. I think they made a slight mistake when they wrote this question. In fact, they say in the solutions that it wasn't quite the question that they intended. They wanted to write a question about lowest common multiples here, but it hasn't actually quite worked out that way. So if you've done this as a lowest common multiples question and you've got the answer of 24, they say in the solutions that schools might want to accept that because the schools will be marking these themselves. But it's not the right answer to this question, and let me show you why. And the simple answer is this. When Xanthe has completed those 8 laps, Yoko's completed exactly 4 laps as well, and Zara has also completed exactly 3 laps. So just from that information in the question, they're all going to be together at the same time after they've done those numbers of laps. So the answer here is actually just 8 laps. It's exactly what they've done after one set of things they've done in the questions. They'll all be back at the start line, and that's the first time it will have happened. And if you're thinking, oh, could it happen sooner than that? Well, actually, definitely not. Think about Zara, for example. After Zara's done 1 and 2 laps, the others will only be like 1/3 and 2/3 of the way through their equivalent amounts, so they won't be at a whole number of laps at that point. Assuming, of course, they're all going at a constant speed. We have to assume they're all going at a constant speed around, otherwise they might meet at all sorts of times. But we do make that assumption in this sort of question. So there we go. Not quite the question that was intended, but actually for that reason I think it makes quite an interesting question. I wouldn't allow the answer 24 from my students here because it's an interesting question that tests really, are you paying attention here, and can you spot what's going on? And so I think actually it's still a very good question. Here's question 24. In a school election, 80% of pupils voted. Of these, 60% voted for the winner. What percentage of the pupils in the school voted for the winner? So the answer is not just 60% here, it's 60% of the 80% that voted. You can do this in 2 ways. You can do it just directly, and that's what I'm going to do here, or you could make up a number of pupils in the school, because for percentages questions, a percentage isn't going to be impacted here in at the end of the question by how many pupils you started with. So if you wanted to, you could just say, imagine there are 100 pupils in the school. Then the number of pupils that voted would be 80% of those would be 80, right? Now I'm just going to say, well, 80% is a percentage. It could be 80 pupils, it could be 160 pupils, it could be another amount of pupils. We don't need to think of it as a number of pupils, we can just think of it as 80% of whatever it is. So I just want to work out 60% of 80%, right? Well, 10% of 80% is 8%, right? Because 10% of 80 is 8. So 60% of 80% is 6 times that. It's 6 lots of 10%. So it's 6 times 8 or 48%. If you were doing it with 100 pupils, that would be 48 pupils. 48% of those that you started with. Okay, so well done if you got that right. Here's question 25 of the Primary Maths Challenge from 2024 then. We've made it to the end. 3 sisters are given £58 to share. Each receives as many pounds as their age. Alice is the youngest, Bethany is twice as old as Alice, and Catherine is 3 years older than Bethany. How much money does Alice receive? This to me is clearly a question that would benefit from algebra. You might be able to do it by some other methods that are essentially equivalent to algebra, but I'm just going to write it down with algebra. So let's let A be Alice's age. Then that would mean Bethany's age is double that, so that's 2A. And then Catherine's age is going to be 3 more than Bethany's age, so that would be 2A plus an extra 3. So essentially what we're being told in this question is that when I add all of these together, A, 2A and 2A plus 3, we're going to get 58 because they're getting £58 and they're getting £1 for each year old they are. So if I add all the ages together, we get 58. Simplifying, A plus 2A gives us 5A, and so we've got 5A plus 3 is 58. If I subtract 3 from each side, that gives 5A equals 55, and dividing by 5, A is equal to 11. That means that Alice is 11 years old, and so Alice is going to receive £1 for each year, £11. Well done if you got that right, and well done too if you've got to the end of this paper and you've worked all the way through it here with me. It's been great to have you here. And if you want to do even more questions like this, you can watch the video on screen now with another complete primary maths challenge paper with video solutions just like this one. And don't forget to go to the Mathsaurus courses website as well, because there you can find all of these questions and more, along with video hints as well as the solutions. There are also loads more free courses to prepare for other maths challenges for all ages 7 up to 18, and content for school maths, and of course my comprehensive 11+ course. There are also regular free webinars for parents and lots of other stuff over there as well, so I really hope you will take a look there soon.